everyone. Let's solve the next question, which is based on subspace and which was asked in the CSIR NET. Which of the following are the subspace of R2 over R? We know that R2 over R is a vector subspace. Okay. Here we have to check which one of the option is correct and which one of the set is a subspace of your R2 over R. We have to check it. The first option says that W1, which is a collection of the order pair but which satisfy the condition that is x plus h must be equal to 0. What is that? They have given you the W in which is a set which is a set which contain the order pair but which is satisfying this condition. We have to check whether it satisfy the condition of your subspace or not. Whether this W1 is a subspace or not, we have to check it. For that, if you want to check the option A is a subspace or not, we have to apply the unit. You have to apply the one-step test, which we have discussed in a previous video. The first thing is, if you want to check any given set is the subspace of R2 over R or R3 over R, just what we have to do? The first thing we have to check whether the identity element is present or not. What is identity element in the R2 over R? The identity element in the R2 over R is 0, 0. Order pair 0, 0 is the identity element. We have to check, okay, whether it is present in W1 or not. Here 0, 0 is belongs to your W1. It means the identity element of R2 over R is present in your W1. Why? Because it is satisfying this condition. In the W1 we have an order pair which is satisfying the condition that is x plus y must be 0. If I take the x value has a 0 and y value is also 0, so we are getting the 0 only. So the condition for this order pair that is satisfied. It means the 0, 0 is belongs to W1. The first condition is satisfied, that the identity element is present in your W1. Next, what we have to do? We have to apply the one-step test. That is, we have to take two elements from this W1. What I have to do is that I have to take two elements from the W1. Let it be has a x1. W1 is equal to x1 comma y1. W2 equal to x2 comma y2. Both belongs to W1. If x1 comma y1 is the element of W1, it means that this condition must be satisfied, right? So x1 W1 is the element of your W1. It means its condition is satisfied. That it means that x1 plus y1 is equal to 0. Similarly, the x2 comma y2 is also the element of W1. It means x2 plus y2 is also must be equal to 0. Now, what the one steps rule says that the alpha into W1 plus beta into W2, if you are able to show that it is an element of your W1, then we can say that W1 is a subspace, right? So, what is your alpha? Alpha is a scalar quantity, beta is also a scalar quantity, W1 and W2 are the vectors of your the given subspace W1, okay? Now, I have to prove this is the element of your W1, what we have to do? We have to consider that alpha into W1 plus beta into W2. We have to consider that. So, let's consider the alpha into W1 plus beta into W2. Alpha into W1 plus beta into W2. Okay. Substitute the value of W1. What is the value of W1? That is x1 comma y1. Okay. Similarly, substitute the value of W2. What is the value of W2? That is x2 comma y2. Substitute it. So now here we got that alpha into x1 comma y1 plus beta into x2 comma y2. Now multiply the alpha with each term of this order pair. It will become alpha x1 plus beta x2 comma beta, multiply and then add it. What you are going to get? Alpha into, first of all you are going to get the alpha x1 comma alpha y1, okay, plus beta x2 comma beta y2, okay. Then now add these order pair, you are going to get alpha x1 plus beta x2 comma alpha y1 plus beta y2, okay. So here the alpha is also real number, x1 is also real number, so alpha into x1 is also real number, so beta is also real number, x2 is also real number, so beta into x2 is also real. If we add this again, it will be a real number. So you can say that alpha into x1 plus beta into x2 is a real number, alpha into y1 plus beta into y2 is also real number. They are real number, but what we have to show, this order pair is going to be the element of your W1 if it satisfies this condition. So it must, if you add these two elements, you should get the identity. Then only we can see that alpha into W1 plus beta into W2 is the element of your W1. So consider, just add these two elements of the order pair. What are these two elements? Alpha into x1 plus beta into x2 plus alpha into y1 plus beta into y2. Okay. Now here we got this equation, and now take out the alpha common. Now arrange the term and take out the alpha common. It will become alpha into x1 plus y1 plus, now take out the common beta common, it will become x2 plus y2. And what is the value of x column? Here we have alpha into x1 plus y1. So what is the value of x1 plus y1? The value of your x1 plus y1 is 0. Substitute it. Similarly, beta plus beta into x2 plus y2 is there. And what is the value of your x2 plus y2? From this equation is 0. Substitute it. So we got, that is alpha into 0 plus beta into 0. Alpha into 0 is 0, beta into 0 is 0, 0 plus 0 is 0. So here we got that the alpha into x1 plus beta into x2 plus alpha y1 plus beta y2 is equal to 0, and both are real numbers. So it means W1 became a subspace. Why? Because alpha into W1 plus beta into W2 is belongs to W1 became a subspace. The first option is correct. Now let's check the second option, whether it is a subspace or not. Okay, W2 contain the next subspace, the next set they have given you W2, which contain the order pair, but they have given you x plus 1, x plus y equal to 1. What is they have given the condition? W2 is a set in which here we have collected the order pair, but the condition is that x plus y should be equal to 1. Now check whether it is a subspace or not. If you want to check whether any given set is a subspace of R2 over R or not, the first thing is we have to check the order pair, the identity element 0 is present or not, we have to check. If I take 0, 0, this is the identity element of your R2 over R, right? But the condition for your W2 is that x plus y must be equal to 1. If I substitute the value x has a 0 and y value has a 0, whether we are going to get equal to 1? No. So the identity element is not present here in W2. The condition of your x plus y is equal to 1 is not satisfied. That's why the identity element, the 0, 0 is not belongs to W2. So if identity element is not present, so how we are going to prove that W2 is a subspace? The first necessary condition for any given set to be a subspace, the first thing is there should be a identity element should be present. So here in W2 the identity element is not present, that's why W2 is not a subspace. Similarly, let's check the W4 whether it is a subspace or not. Okay, the condition for this W4 is the x minus y. It is a collection of those order pair which satisfy this condition, that is x minus y is equal to 1. Now substitute the identity element is 0, 0, right? Substitute the value of x equal to 0, substitute the value of y equal to 0. 0 is not equal to 0 minus 0 is 0. 0 is not equal to 1. Again the condition for the order pair 0, 0. Again this condition x minus 1 is equal to 0. For this order pair it is not satisfied. It means the 0, 0 order pair is not present in your W4. This is W4 is not present in W4. That's why it is not a subspace. Okay, so D option is also not a subspace. Now similarly you can check the C3, it became a subspace. Let's check the third option, C option, that is W3 contain order pair which satisfy this condition. The condition is x minus y must be equal to 0. If I substitute the value of x has a 0 and y value has a 0, 0 minus 0 is again a 0. So the identity element is present in your W3. Okay, and if you want to prove it is a subspace or not, we have to apply the one step rule, that is alpha into W1 plus beta into W2. Okay, so the first thing is we have to take the W1 value and W2 from your V3. We have to take two elements from the W3. The elements of your W3 is in the form of x1 comma y1 and x2 comma y2, and these two elements W1 and W2 must satisfy the condition. What is that condition? X minus y. Here we have order pair x comma y, so this condition must be satisfied. So here x1 comma y1 is there, so it must satisfy the x1 minus y1 must be equal to 0, and x2 minus y2 must be equal to 0. Okay, now consider the rule, that is alpha into W1 plus beta into W2. Now substitute the value of W1. The value of W1 is x1 comma y1, and the value of your W2 is x2 comma y2. Okay, now multiply and add both the order pair. It will become alpha into x1 plus beta x2 comma alpha into y1 plus beta. So here these two elements, the alpha into x1 plus beta into x2, this is also a real number, and alpha into y1 plus beta into y2 is also real number. Okay, now we have to check whether both are real number, both are in the order pair, but this element alpha into W1 plus beta 2 is going to be the element of W3 if it satisfies this condition, right? So we have to apply this condition. We have to just subtract these two elements. If it became 0, then we can say that alpha into W1 plus beta into W2 is also the element of W3. So here we have alpha x1 plus beta x2 minus alpha y1 plus beta y2. Okay, that is equal to, now take out the alpha term on one side and beta term on one side. So just arrange this term. It will become alpha x1, open this bracket, it will become alpha x1 plus beta x2 minus alpha y1. Here it will have a positive. If you apply the negative, if you open the bracket, it will become minus beta 2. Now take out the alpha common and take out the beta common. It will become alpha x1 minus y1 plus beta x2 minus y2, and we know the value. What is the value of your x1 minus y1? That is 0. What is the value of your x2 minus y2? That is also, substitute it, you are going to get 0. So here we got that, we can see that alpha into W1 plus beta into W2 is also the element of W3. That's why W3 became a subspace of your V3. Why became it subspace? First of all, you have to consider your alpha into W1 plus beta into W2. Okay, so we are going to get the order pair, and the element of the order pair become real numbers, and they must satisfy the given condition. Whatever such that they have given the condition, this must be satisfied. So here we got that here two options are correct. One is option A, another one is option C. Thank you.